So in the last lecture we've looked at this very simple case of S is converted into P. And we said, okay, well the S dt equals minus V, P dt equals V. So the rate of the reaction V is positive when P is made, and V equals K plus times S, K minus times V. Now, if I have this, then the A dt is minus V, the B dt is minus V, the C dt is V, and V equals K plus times A times B minus K minus times C. Okay, so when you have mass action kinetics, so not enzyme catalyzed reactions, not biochemical connections, but chemical kinetics, mass action kinetics, and you have this, then the rate is always described of a reaction by a product of all the substrate concentrations times a K plus, K minus times the product or a product of that. Okay, so if you have multiple products, and you get the product of the product concentration. So you get dA dt, dB dt, dC dt, dD dt, and V is going to be K minus times A times B times C times V. So the rate of the reaction is the forward part. In that direction is a constant times A times B, where A is the concentration of A and B is the concentration of B. The backward reaction has the same logic. You have a rate constant and the product of the two product concentrations C and D. Okay, so now if I would have 2A goes to A2, and what happens now? Okay, so first of all, the rate with which the dimer is formed is going to be equal to V, right? So because we always define V as positive if you make a product. Okay, so now one product is made per unit reaction. But the rate with which you lose A, right, is twice as high as the rate with which you gain A2, because A2 is composed out of two molecules of A. So if I give you 10 euros per unit time, I'm giving you 50 cents per unit time. So the rate of the 50 cents is twice as high as the rate of the euros, because 1 euro is composed out of two 50 cents. And here the rate would be K plus times A squared minus K minus times A2. Why the squared? Well, this is just A plus A after all, so that is K times A times A. Okay? So we typically write 2A. Now let's now say that 2A is converted into 3B. Okay. Now the rate of the reaction is positive when I make B. So dB dt is going to be equal to V. But per unit reaction I make 3 molecules of B. And per unit of reaction I lose 2 molecules of A. I lose 2 molecules of A. So the rate of the reaction now is going to be K plus times A squared minus K minus times B to the power 3. Right? Because this is A plus A goes to B plus B plus B. And we always take the product of the product concentration and the product of the substrate concentration. Okay? So now if I have 2A plus B gives a 3c plus 5v. Then dc dt, right, is going to be positive function of the rate times 3. Dd dt is 5 times v. dA dt is minus 2 times v. And dB dt is going to be minus v. And the equation, the chemical kinetic equation, will be k plus times a squared times b minus k minus times c to the power 3 times d to the power 5. Okay? So that's the logic with mass action kinetics. That's a simple rule. Now these guys, all the 2's, these guys, those, all these coefficients are called stoichiometric coefficients. Okay, stoichiometric coefficients. Okay. So the reaction stoichiometry is 2a. With respect to A, with respect to B, it's 3b. Yeah? Alright, so it's important to practice this a little bit. It's not really hard, it's just something that will come naturally in after some practice, and especially this type of example is hard for people. But eventually you'll get the drift. It's not very complicated. Alright, go and practice.